Okay, engineers, this is the case of repeated roots when you have repeated values of lambda or eigenvalue. Now I'm going to start with an example and see what is the problem. Okay, now following the same procedure, we will use this formula, the determinant of A matrix minus lambda identity matrix equal to 0. I usually jump directly to the matrix, to the determinant. You can do that also, but the determinant will be, because A matrix minus lambda identity matrix only affects the main diagonal, then what happens is that you will have 3 minus lambda, the other is the same, this is the same, and not only minus 9 minus lambda, and that equal to 0. You can save a lot of time there. Okay, now the result of this is going to be this times this. I'm going to do the multiplication already. 3 minus 19 minus 9 minus 27, and then minus 3 lambda, and then plus 9 lambda, and then plus lambda squared, and then this times this, plus this will be 18 times 2 is going to be 36. Alright, is that correct? Yeah. Okay, so let's see what happens. Lambda squared, and then this number is going to be 6 lambda, and then 36 and minus 27 is going to be plus 9 equal to 0. Okay, now two numbers in which the multiplication is 9 and the addition is 6. So that is going to be plus 3 and plus 3. And as you can see here, lambda 1 is equal to 3 and lambda 2 is equal to 3, minus. So they are repeated real roots. Okay, the problem will be to find the second solution, because the first solution, let's find the first solution. To find the k vector, with this we just found the values of lambda. To find the k vector, we are going to use this formula, A matrix minus lambda identity matrix times k vector equal to 0 vector, by replacing some values of lambda. So let's use lambda 1, sorry, this is not an S, lambda equal to minus 3. So we replace it here. What I'm going to do is to jump some steps. I'm going to replace the value of lambda here. So it's going to be 3 minus 3 minus 18, 2, minus 9, minus 3, and then zeros. And each column, the first column is for K1, and the second column is for K2. Okay, what happens here is, this is 6, minus 18, and then 2, and then this is going to be minus 6, 0 and 0. Okay, so what operation should we do? What about this operation? I can do this equal to 1 because 6 times 3 is equal to 18, but I can do this operation, minus 1/3 of the row 1 plus the second row, and we save it in second row. If I make 1/3 of the 6, it's going to be 2, and minus 2 plus 2 will make that 0. Okay, so the result will be something like this, 6 minus 18 and 0. And then this times this, minus 2 plus 2, 0. Now what about this one? Minus and minus positive, 18 over 3, 6, minus 6, 0 and 0. And remember that this should happen. If this doesn't happen, then you did something wrong. So this means that you are okay. Okay, so what is left, engineers? So what is left is the first row, 6k1 minus 18k2 equal to 0. Let's clear for the value of k1 or k2, whatever is easier. I'm going to clear k1. So this to the other side, 18 over 6, 3k2. Okay, so I'm going to choose a value of k2. I'm going to choose an easy value. k2 is equal to 1. So k1 is equal to 3. Okay, so what is the first solution? The first solution then is equal to my k vector, 3 and 1, 3 and 1, exponential of what? Of minus 3t. Okay, so that is for the first solution. That is no problem. The same procedure we have seen so far. Now, the problem is to find the second solution. I cannot use the same eigenvalue because it is actually the same. If I use again lambda 2 here equal to minus 3, what I'm going to get is actually the same solution. X2 vector will be 3, 1 exponential minus 3t. And this is actually the same solution if I follow the same procedure. Okay, so I cannot use the same procedure to find the second solution. Now, if you remember from the course, when you have repeated roots, I'm going to write like, if your first solution was y1 equal to exponential of t, or x, in that case, your second solution will be x times exponential of x. So the fix was just to multiply x as many repetitions they were. But it's not the same for these problems. The second solution is something like this. The second solution is x2 vector. This is formulas. The second solution will be something like this. Second solution is going to be k vector t exponential of lambda t plus p vector exponential of lambda t. This is the second solution. Alright? Now, the k vector, you already have it, is this one. This is the k vector. The value of lambda, yeah, you already know it. The only thing that you don't know here is the value of p vector. And how are we going to get p vector? So that's something that you don't know. Okay? Now, this is not the case, this is 2 by 2. What if you happen to have a 3 by 3 problem where you have 3 repeated roots? So the third solution will be something like this. The third solution will be something like this. K vector t squared over 2 exponential of lambda t plus p vector t exponential of lambda t plus q vector exponential of lambda t. That will be the third solution. Okay? The k vector is from the first solution. The p vector will be from the second solution that you are supposed to know it because you already have the second solution. And the q vector, that will be the new thing to calculate for the third solution. Okay, now let me give you the formulas to find p vector and q vector. To find the p vector, now remember the k vector, we use this formula to find the k vector. Now the p vector, I'm going to write here for the first solution here. The first solution, you use a matrix minus lambda identity matrix, k vector equal to 0 vector. Now, to find the p vector is going to be something very similar. To find the p vector is going to be the same, a matrix minus lambda identity matrix, but here you have a change. P vector equal to k vector. And that is the formula to find the p vector. Now, to find the k vector is going to be something like this. The base will be the same, a matrix minus lambda identity matrix times q vector equal to p vector. Now check this out. For the first solution, this is the formula that we already know. For the second solution that you have to calculate p vector, the only difference between this and this, you can see is the same here, but the only difference here is that the k vector switch places with the 0 vector and p vector shows up here. And for the third solution, the p vector goes in this position and you get the q vector. Okay, so those are the formulas that you are going to use. You can check this in the book. But for this example, let me find p vector. Let's find p vector here. And let's find this p vector. Now, as you can see here, the formula is exactly the same. Instead of being 0 vector and k vector, now is k vector and p vector. So what I'm going to use is actually this formula. It is exactly the same because this part doesn't change. It's going to be 6 minus 18, 2, and minus 6 from here. But now instead of being 0, 0, which is 0 vector, now it's going to be k vector. What is k vector? K vector, we calculated here, 3 and 1. 3 and 1. Okay? And now the first column will be P1 and then the second column will be P2 because P vector is something like P1 and P2. Just like the K vector, K1 and K2. Okay, now this is going to be very easy, engineers, because this part is kept the same, then it's going to be the same operations. So you don't have problems there. The same operation will apply. Minus 1/3 of the first row plus the second row, and you save it in the second row. So the same operations, actually this doesn't change. 2 and minus 6, it doesn't change. What it changes is here. Minus 1/3 times 3 is going to be minus 1 plus 1, 0. Here it is 0 and 0 because it's the same operation. This times this and this times this and 0 and then 3 here. So again, this should happen. If it doesn't happen, then you did something wrong. But even with the p vector, it happens. So what happens here is that you get the following equation. For this equation, it is going to be 6p1 minus 18p2 equal to 3. Okay, so from there, I'm going to clear one of the values. P1, I'm going to clear this to the other side, 3 plus 18 P2 divided by 6. So that means 1/2 plus 3 P2. So that is the equation. So what I'm going to do right now is to give a value of P2, whatever the value you want. Okay, I'm going to choose P2 equal to 0. Now, this is a difference between the P vector and the K vector. On the K vector, you cannot choose 0. But for the P vector and the Q vector, you can choose 0. There is no problem there. So what is the value of P1? P1 is equal to, because this is 0, then you have 1/2. Okay, so the P vector is equal to 1/2 and 0. So your second solution is going to be something like this. In the equation, K vector is 3 and 1, t exponential of minus 3t, plus P vector, which is the new one, 1/2, 0, exponential minus 3t. And you found the second solution. And that's it, engineers. This is the procedure to find the second solution. If you happen to have, again, 3 by 3 and you have 3 repeated roots, this will be the process. But for the Q vector, what you have to interchange here is 1/2 and 0. And the same operations apply. But this is 2 by 2, just example. Now, just let me write the general solution. The general solution is going to be C1, first solution, C1, 3 and 1, exponential minus 3t, plus C2. My second solution is this big solution, 3, 1, t, exponential minus 3t, plus 1/2, 0, exponential minus 3t. All this is my second solution. And this part is my first solution for repeated roots case. Alright? On the next video, we will see what to do with imaginary roots. See you in the next one.